In late July 2026, a Chinese jet took off from Shanghai and flew for nearly 2 hours over unfamiliar territory. That flight was not routine. It was a test that could break a duopoly that has controlled the skies for 50 years. Boeing and Airbus have owned commercial aviation for decades, and China just proved it no longer wants to depend on either. This is the story of the C919, its high-altitude cousin, and the engine China is racing to build entirely on its own. By the end, you'll understand why this single aircraft program could reshape who controls the skies over the next 20 years, and why countries far outside China are already watching this program with intense interest. China's aviation push is not random ambition. It is a core part of a national strategy for technological self-sufficiency. The country's aviation market has grown massive, but its planes still mostly came from Boeing in America or Airbus in Europe. That dependence created a risk, because foreign sanctions or embargoes could ground large parts of China's fleet without warning. So Beijing built the Commercial Aircraft Corporation of China, known as COMAC, to design a true competitor from scratch. Its flagship jet is the C919, a narrow-body aircraft aimed directly at the Boeing 737 and the Airbus A320. The program launched in 2008, and it took nearly a decade of work before the first aircraft was even ready to fly. Final assembly finished in November 2015, and the maiden flight happened in May 2017, 6 years after the program began. Certification took even longer, with China's Aviation Authority finally granting the type certificate in September 2022, 14 years after launch. The first C919 reached a customer in December 2022, and it began flying regular commercial routes in May 2023. That is 15 years from launch to paying passengers, showing just how difficult building a competitive airliner really is. The standard C919 carries between 158 and 192 passengers, with a range up to roughly 5,555 kilometers, depending on configuration. It uses composite materials and modern aerodynamics to cut weight and improve fuel efficiency compared to older aircraft designs. But its early versions still rely on Western-made engines from CFM International, a joint venture between America's GE and France's Safran. That single dependency is exactly what China is now working to eliminate, and it's the real story behind this next development. In China's western regions, airports in Tibet and Qinghai sit above 3,000 meters, where thin air makes flying genuinely harder. Lower air density at that altitude reduces both engine power and aerodynamic lift, making takeoff and landing far more demanding. COMAC answer was the C919-600, nicknamed the Plateau, a variant built specifically to handle these extreme high-altitude conditions. It completed its maiden flight from Shanghai Pudong International Airport in late July 2026, the flight that opened this story. Engineers shortened the fuselage and upgraded the avionics, changes designed to sharpen takeoff, climb, and landing performance in thin air. This was not a side project. COMAC had already signed a 2023 agreement with Tibet Airlines to co-develop this exact variant. That partnership turned into a firm order for 40 aircraft, giving the Plateau a real customer before it ever left the ground. It's built to compete directly with Airbus models that have historically dominated high-altitude routes across mountainous regions worldwide. Underneath both versions sits the bigger long-term goal: an engine that owes nothing to any Western supplier. That engine is called the CJ1000, China's domestic turbofan built specifically to eventually replace the imported CFM engines on the C919. Beijing's current 5-year plan explicitly calls for localizing critical components like this engine, not as an option, but as a target. A fully domestic engine would make the C919 far more attractive to countries nervous about relying on U.S. linked supply chains. It would also insulate China's entire commercial fleet from any future sanctions, targeting foreign-made aircraft parts. This same engineering push shows up clearly in China's military aviation, which reveals just how far its aerospace capability has come. China is already scaling up production of the J-20, a fifth-generation stealth fighter jet flown by its Air Force. More striking, China is the only country to have flown prototypes of sixth-generation fighters, with test flights starting in late 2024. These aircraft are designed with advanced stealth, powerful sensor systems, and a potential combat radius of 2,500 kilometers. Powering some of these jets is the WS-15 engine, already integrated into enhanced J-20 variants and built for the sixth-generation fighters. Its power-to-weight ratio is considered comparable to America's F-135 engine, which powers the U.S. F-35 fighter jet. So the same country building a commercial jet is simultaneously closing the gap in the most advanced military aircraft on Earth. Back on the commercial side, the stakes are enormous because China's own fleet is expected to more than double in size. Forecasts show China's roughly 4,652 commercial aircraft, potentially growing past 9,700 planes over the next 2 decades. Every C-919 that fills part of that demand is money that stays inside China, instead of flowing to Seattle or Toulouse. It also builds domestic industrial capacity, giving Chinese suppliers and factories decades of manufacturing experience they never had before. But going global is a different challenge entirely, one COMAC has not solved yet. To sell C-919s outside China, the aircraft needs certification from bodies like America's FAA or Europe's Aviation Safety Agency. Neither has certified the C-919 yet, and without that approval, most international airlines simply cannot legally fly it. COMAC also needs global maintenance networks, spare parts pipelines, and after-sales support, all of which take years and serious investment to build. Cost is one advantage working in its favor, since the high-altitude variant and future CJ-1000-powered jets promise lower operating expenses. That could appeal strongly to cost-conscious airlines in developing regions that Boeing and Airbus have never prioritized. The C-919 program was never really about one airplane. It was a testing ground for an entire aerospace industrial ecosystem. Its success is already clearing the runway for the C-929, a future wide-body jet meant to challenge the Boeing 787 and Airbus A350. If China nails both the domestic engine and international certification, it stops being a regional player and becomes a true global rival. That would not just squeeze Boeing and Airbus, it would ripple through their entire network of parts suppliers worldwide. Aviation has become one of the clearest signals of China's 21st century economic and geopolitical ambitions. A country that builds its own engines and its own stealth fighters does not stay dependent on anyone else for long. The Plateau's first flight in July 2026 was a small test flight on paper, but it represented a much bigger shift underneath. It showed a country closing the technology gap on 2 fronts at once: commercial jets and military air power, using the same expertise. If you want to see how this same kind of self-sufficiency push is playing out in China's military buildup specifically, the next video covers it in full. Watch that one next, because the numbers behind China's military expansion are even harder to ignore than this aircraft story.